Hello everybody. Today we're going to be going over compound interest problem at the IB Math Studies level. So the problem tells us that Cyan invests 50,000 Australian dollars into a savings account, which pays a nominal annual interest rate of 5.6% compounded monthly. Okay, that's a ton of information. And so part A says calculate the value of Cyan's investment after 4 years and give the answer to two decimal places. Okay, for all of these problems, um, there's going to be five variables. Okay, and in all these problems, there's always going to be one that you do not have, but only one. The other ones, the problem will we give it to you always. Okay, so really get familiar with the equation on the formula booklet and understand what each of them is asking you. Okay, so FV is future value. So if I invest in something, how much is it going to be worth in the future? PV is present value. R is going to be the nominal annual interest rate. K is the number of periods, and N is the amount of years. Okay, so since Cyan invests 50,000 Australian dollars, there we know the present value right away. Okay, then it says that the nominal annual interest rate is 5.6%, so that is going to be our value for R. Um, and it tells us compounded monthly. Okay, so in this scenario, K is going to be 12. N is 4 years, and we do not know what FB is. Okay, so this is going to be our variable in this scenario. Okay, we could even put in X here. It makes it easier to visualize. So we're going to have that X equals 50,000 times 1 plus 5.6 divided by 100 times 12 to the power of 12 times 4. Okay, and this is going to give us 62,520.97 Australian dollars. Okay, one thing I want to point out here, for R, we know that it's 5.6%, and here you might be thinking, if it's a percent, I should write it as uh, 0.00, sorry, 0.056, right? Because this is the same as 5.6%. Okay, this is true, but for the context of the formula, you don't really care about that. Okay, so don't get yourself tripped up on that. Okay, it's a little bit counterintuitive, but that's why just get used to the formula, get familiar with it. The formula just kind of assumes that this is 5.6%. Okay, even though in reality this would actually be 560%. Okay, so just trust the formula, trust the process. Okay, and now for part B, it tells us that after the 4 year period, Cyan withdraws 40,000 Australian dollars from her savings account and uses this money to buy a car. Okay, it is known that the car will depreciate at a rate of 18% per year, and the value of the car will be 2,500 AUD after T years. Okay, there's two things here. One, again, there's five variables. One of them is going to be missing. That's how all the problems are going to be. But two, since we are now depreciating, okay, instead of adding here, the formula changes to minus, okay? And that's something the formula booklet does not tell you. This version is depreciate, okay? This version is when like it appreciates or compounds, okay? So we know that the value of the car will be 2,500 AUD. We know that CN withdrew for 40,000 Australian dollars and uses that to buy the car, so the value of the car has to be 40,000 AUD. We know that it will depreciate at 18% per year. It also tells us, if it doesn't tell us if it's monthly or weekly or anything like that, we assume it's per year, okay? That's another assumption that is going to happen in all problems. If it doesn't tell you if it's monthly, it's per year. And so K is going to be equal to 1. and we don't know what n is, which makes sense because we have to find the value of t, okay? In the context of the problem, t is going to be equal to n. I'm just pointing this out so it makes sense in the formula booklet, okay? So plugging all this in, I'm following up here. 100 times 1 because k equals 1, and the exponent is going to be t. Okay, and there's a lot of ways to solve this, but really at this point of the problem, like, this is the hardest part, just setting it up. Now you can play with your calculator, find many ways to do it. The way that's easiest for me is that on the calculator, I go to y equals, okay? On L1, I put 1/2 of the equation, and on L2, I put the other half of the equation, okay? After this, I do calc, intersect. Whatever that point shows up is the value of t that makes this equal. The reason this makes sense is because L1 is going to be like up here, okay? This is L1 at 2,500, okay? And then the depreciation is going to be like, I don't know, it's probably going to be something like this. I'm just making it up, right? This line is going to be L2, which is this whole chunk. And this right here, the point where they intersect, it's going to be the value of t. Okay, it's going to be the value of t, comma, 2,500. Okay, because at 2,500 is where the equation makes sense. All right, so that's the way I do it. I know you can also do it with like a geometric sequence, but I feel like that gets really tricky. This takes longer because you have to graph it and then intersect it, but it's also the most reliable way. Okay, so after you do that, you're gonna get that the value of t is, you're gonna get that the value of t is 13.9711, or it's the same as saying around 14 years. Okay, and to get full credit, you have to show your work, right, all the time. So if you just write down the same as I did here, this is going to be L1, this is going to be L2, I did calc intersect, and t gave me this, you're going to get full credit, okay? And it's, in my eyes, the most reliable way to do it, okay? I hope it helped.